Hey everyone, welcome back to Cam Room 5. Today we're going to be starting a very new topic for our upcoming set of videos, which is going to be experimental chemistry. We're going to be looking at how various chemical techniques and experiments are set up based on the O-level chemistry syllabus. So the first section that in the video we'll be doing is the collection and drying of gases. We're going to see which pieces of apparatus are used to collect gases, to dry gases, which chemicals are used. Second thing is going to be the qualitative tests. So we're going to do the qualitative analysis. Qualitative means we are not concerned with the amount, we are concerned with the identity of gases or ions. The third thing is going to be, The third thing is going to be separation techniques. We're going to look at various separation techniques and we'll explore them. First thing in the video, today we're going to be talking about collection of gases. So when we talk about collection of gases, first question we ask ourselves, do you know the density of the gas? It's either a yes or a no. Density, which means mass per unit volume. So if you know the density, the gases can be either heavier or lighter. Heavier means they have a density higher than air. So air is itself a mixture of gases, and we compare the density with air. So whether your gas is heavier or lighter, lighter means has lesser density than air. Lesser density than air. If your gas is heavier than air, then based on the relative weight, based on the relative forces, they're going to be attracted downwards. So we collect them using downward delivery method. If your gases are heavier, which means they don't have as much weight as air, they move upwards, and that's why they're collected with the upward delivery. If you don't know the density in the first place, you then ask yourself, is the gas soluble or insoluble? Obviously in water we are talking about. So if your gas is soluble or insoluble, that also has an impact on the method that you go for. If your gas is insoluble, which means it doesn't dissolve in water, you go for collection over water, where you collect the gases on the surface of water. If your gas is soluble, then you can't use the collection over water because your gas will dissolve. So you go for a gas syringe method, and we'll explore that as well. So 1, 2, the third method being collection over water, and fourth being the gas syringe method. We have 4 methods for the collection of gases. Imagine you have 2 test tubes. There are delivery tubes around them, and there are gas jars. So 2 test tubes, which definitely will have the chemicals in them for the reactants. There are delivery tubes set in 2 different directions. A cork or a rubber bung is fixed on the top of each test tube to not allow the gases to escape. And there are gas jars. Imagine your reactor is in the test tube, which is going to produce a certain gas. Now, the gases are produced and they're collected by the delivery tube. So the delivery tube delivers the gas. And based on the relative density of the gas, by relative I mean relative density compared to the air. So based on the relative density, your gas jar is fixed in a certain way. On the left you can see the gas jar is inverted and fixed on top, which is for less denser gases. And on the right, the gas jar is straight, and it's facing downwards. So for example, gases like chlorine or HCl, they're heavier gases, so they're collected by the downward delivery method. You can see pale green gas being collected. So chlorine, hydrogen chloride gas, sulfur dioxide gas, these gases have a higher density compared to air, so they're collected with the downward delivery method, where they are collected in a gas jar, and the gases are collected in a downward direction. If your gases are lighter, like ammonia, hydrogen, they're collected in the upward direction with an inverted gas jar. So hydrogen, oxygen, ammonia, they're collected by the upward delivery, which is drawn on the left of the screen. So there are 2 different methods. Remember, the upward delivery and downward delivery works with gases and their densities. You should also notice one thing, that when a gas is collected, air is displayed. So in the upward delivery method, you can see the air moves downward, because when the gases go upwards, obviously they're going to shift the gases downwards. And the opposite happens in the downward delivery method. So when the gases are collected downwards, the air moves upwards. So upward delivery for less denser gases, downward delivery for more denser gases. Now, if you don't know the density of the gas, you go for collection over water, where you have a test tube and a long delivery tube fixed with a water trough and inverted test tube. A test tube is fixed with a delivery tube. Obviously, there is a rubber bung on top of the test tube to not allow the gas from escaping. There's a water trough around the delivery tube filled with water reservoir, and there is an inverted test tube in the center of the water trough. The water trough and the inverted test tube are both completely filled with water. You can use a measuring cylinder as well, but sometimes people use test tubes. You can use a measuring cylinder as well. They're both filled with water. So when the reaction begins and the gas starts moving from the delivery tube into the water trough, obviously water is more denser. So you will see bubbles of the gas, and you will see the gas start moving upwards into the test tube or the measuring cylinder, and the gas will start occupying the space in the test tube. So the gas starts being collected and occupying the space in the inverted test tube or the inverted measuring cylinder, and it displaces the water. This method is known as the collection over water, because the water moves downwards and the gas is collected upwards. It only works when the gases are either insoluble in water or they are very, very, very negligibly, sparingly soluble in water, which means the same thing. So which gases work over here? Carbon dioxide, carbon monoxide for sure, nitrogen, oxygen. Oxygen and carbon dioxide are both sparingly soluble. It doesn't work for ammonia. It doesn't work for SO2. It doesn't work for chlorine or hydrogen chloride, because these gases are soluble in water. So you can never collect these gases on top of water, because they won't be collected. They would dissolve in the water. You will get a solution of these gases, not the collection. The final method works if you don't know anything about a particular gas. So you fix a gas syringe. You take your conical flask where you're going to performing the reaction, and whatever reaction happens, you're going to fix a rubber bung on top of the conical flask so no gas escapes. When the reaction begins, for example, a reaction between calcium carbonate or acid, a reaction with metal and acid, or any other reaction, the gas can't be escaped, like it can't be escaping from the top, so it starts being collected in the gas syringe, and you will see that the gas starts collecting over here. How will you see that? There is a black line, there's a black ring which moves. So there's a thicker black ring which moves in the gas syringe, and it lets you know, it lets you see what volume in the gas syringe is being collected. So the line moves, the ring moves, and you notice the amount of the gas collected. Moving forward, we're going to be talking about the drying or dehydrating agents. Dehydrating agents or drying agents are substances which remove the unwanted moisture from any gas. So by drying, I actually mean removing the unwanted moisture from a gas. Make sure the drying agent should not be reacting with the gas. That's not the job of the drying agent. So imagine you have a U-tube shaped glass tube, which is ironic. And there's another setup, I'll talk about it. The U-tube has been filled with fused calcium oxide or fused calcium chloride. These are both drying agents, calcium oxide or calcium chloride. Another common drying agent is concentrated sulfuric acid. You can see the delivery tubes allow the gases to move inwards, and then they're collected afterwards when they're dried. So calcium oxide and calcium chloride are both good drying agents, and then sulfuric acid in the concentrated form is also a good dehydrating agent or a drying agent. You allow the moist gas to be moving in and the dried gas to be moving out. Just notice one thing, that the first delivery tube is actually inserted in the sulfuric acid. So when you're using sulfuric acid as a drying agent, the incoming delivery tube should be completely immersed in the sulfuric acid, but the outgoing, the second set of delivery tube, should be higher than the level of the acid. So the gases are collected on the top of the acid and then they're collected outwards. So the position of the delivery tube level is really important. You can use calcium oxide and calcium chloride in the fused state, which means the dried state, for any gas except for sulfur dioxide, sulfur trioxide, or carbon dioxide. You can't use it. because these gases are acidic and calcium oxide is basic. You don't want a reaction to happen, right? So the acidic gases can't be dried using calcium oxide. Similarly, ammonia can't be dried using sulfuric acid because ammonia is a basic gas and sulfuric acid is an acid. You don't want a neutralization reaction to be happening. So you keep your drying agents based on what kind of gas you're drying. Calcium oxide and calcium chloride are good drying agents, but they can't be used for acidic gases. And concentrated sulfuric acid is also a very good drying agent, but it can't be used for ammonia, otherwise a reaction would happen and neutralization would occur. Second thing you should keep in mind is the position of the delivery tube. The first delivery tube should be inserted in the concentrated sulfuric acid. The second set of delivery tube should be higher than the level of the acid so that the gases can be collected after drying and then they move through the delivery tube. I hope I'm clear, guys. So in the next video, we'll talk about a new topic. Stay tuned, guys. Thanks.